All right. So as Katie mentioned, talk is on improving HashiCorp Vault security with data visualization. I am Martez Reed. I am currently the Director of Technical Marketing at Morpheus Data. Can be found on LinkedIn, Twitter, as well as GitHub. All right, so let's dive right into it. Actually, we'll go sort of 2 years in the past. I gave another talk, a Hashi talk, 2 years ago. It was actually on HashiCorp Vault operational intelligence. And so what the talk was about was how can we mine essentially data out of HashiCorp Vault to give us insights into our usability, what's being used as far as HashiCorp Vault. So the challenge with that was the focus was on data essentially from the past. And the other aspect was that it lacked context in the broader sense of what large organizations have to deal with. So there's a lot of different moving parts, a lot of different pieces that have to be accounted for. So how do we take that next step in terms of what I would term as evolving operational intelligence? So what's next for HashiCorp Vault Insights? There are more questions to be answered. And so how can we answer some of those questions? So some of the questions that might come up outside of the more operational focused questions, the questions that are, well, who's using this particular backend? Who's accessing this particular secret? All those things. And when you think of them, they're things that are related to events that happened in the past. So what has somebody done already to the system? And not to go sort of very into the future, Terminator-like, but the idea of being proactive in the sense of kind of those common questions that we all have in our heads that if somebody actually asks you is somewhat difficult to answer. So the idea of something like who has access to our top secret. And so that would be potentially the context of the value of the secret, coupled with potentially existing data from usage of secret that's most commonly used, and then aligning it with information that we know about the system, but that is quite difficult to actually unlock. And so that's one of the things that we go through the process of creating our policies and assigning access, and we have a fairly good concept of who has access. But the challenge becomes in that moment, that instance, that someone asks you the question of who has access to this particular secret. The question you kind of have to ask yourself is, how long would it take me to figure out that answer? Of parsing through the policies that I've created, the access that I've granted to that policy, and then ultimately who's able to access that piece of information. Next thing might be is who can generate dynamic credentials. One of the really great benefits of HashiCorp Vault is the ability to create dynamic credentials for databases or public clouds. But the challenge becomes who has access similarly to secrets or static information, who can actually generate those credentials. And then along the same lines, what policies can grant access to a particular secret? And then as well, what secrets does the policy grant access to? And so I may have a policy for my developers or my DBAs or my ops folks, whoever it might be. And I look at the policy, and the question of looking at the policy becomes, I've written this policy, but what does it really grant access to? It's a challenging question to ask, but one of those things that is super valuable to be able to have the answer to. And then the other challenge becomes, especially when you start talking about wildcards in terms of policies that you've included to grant access to a given path and the components under that path, is in the event that a new secret were to be added, am I granted access to that new secret? Or is it something that's not going to allow me to get access to that secret? And so it's definitely one of the challenges of creating policies is you kind of fuddle around with, is this permissive or too permissive or just the right level of privilege that's being granted for the secrets? And then kind of one of the extra questions is who granted the extra access? And so oftentimes when we hear about security breaches and things like that, it's when did they access it? What did they access it? when did they access it and what did they access? And then oftentimes the sort of trailing question is, well, how are they given that access if it was a level of access that wasn't assumed to have been granted to that particular account or that role? This is where we start to delve into intelligence aggregation. Oftentimes it's brought up with cybersecurity is being able to harness the information about the environment and then aggregate that into something useful. The challenge becomes it's a concept or a topic that is very much in sort of a compartmentalized aspect of, well, this is something that the security folks do, and they've got whether it's the threat intelligence security feeds from various different sources across the world, and I'm leveraging a particular vendor's capabilities of what they're doing to collect that information. And kind of the thing I would say is, how can we start to harness that for given products and given capabilities? So something like a HashiCorp Vault. One of the challenges that we have now is the explosion of different workloads and services and capabilities of whether it's in an on-prem environment, public cloud, virtual machines, Kubernetes, bare metal. It's how do I start to collect all these different data sources and provide that aggregate of intelligence, and then ultimately also provide it in a usable format. In terms of consumability, the challenge oftentimes with what we have now from a vault policy standpoint is we're starting to have to, as humans, map those in code. And code is great for being able to create things programmatically, but some of the challenge becomes, how can I get the conceptual context for something just at a glance from looking at the code? It can be very difficult, especially if you start to talk about an individual that is net new to the organization or hasn't worked with the particular deployment of Vault, or even when we start to talk about things like pull request of Vault policies, to really be able to understand the context that and implications that go along with us accepting that pull request. If I accept this pull request for these changes to the Vault policy, what actually am I granting access to? It can be somewhat challenging. And so that's where we have data that lives in these different aspects of our organization, whether it's something like a SIEM or a logging platform like Splunk, source control like GitHub or GitLab, whatever your source control might be. Oftentimes Active Directory is where a lot of my human accounts are stored, as well as potentially service accounts. And then obviously the HashiCorp Vault instance itself. So how can I start to wrap my head around gathering all these different pieces of information and combining them? So this is where, in my opinion, a graph database comes into play. As part of preparing for this talk, graph database is one of the things I had often heard about, and it never really sunk in for me what context I could really use it for. My background is traditional operations. So, I mean, I've obviously worked with databases and NoSQL databases and relational databases, but kind of always heard about graph databases and never really understood the context. One of the things I would often associate it with was, oh yeah, people use it for recommendation engines. For when I go to Netflix, how does Netflix know to recommend I should watch these movies over these movies? But then to take it a step further, I obviously went to Neo4j's website and started to understand some of the other use cases for graph database to, number one, be able to provide access to that data in a relational format, as well as being able to visualize the relationships between particular objects or entities. In this particular visualization on the screen, it's a very generic talking about generic example talking about relationships of human beings, and in particular along the lines of social media, who posted, who liked a particular post. And so kind of the idea is, how can we take that capability and start to inject the intelligence we have about our environment into something like that to provide that insight? So we'll look at kind of that first one, visualizing secrets access. As I mentioned, the challenge becomes somebody comes to you, your manager, a VP, whoever it might be, ask a question of, I'm concerned about what we've got in Vaults. I know it's secure. I know it's really great product. And I know it's got all the bells and whistles to do what we need, but I'm concerned about, we've put that data in there and how can we how can we understand who has access to what particular secrets and those things? So this is where we kind of started off of the genesis of things with a secret or a static credential. And then, so in this particular case, we're talking about a key value particular object. And so let's say we've put an API key into our Vault instance. So the question then becomes, who has access to the API key? The common question would be, well, a user or a machine has access to the API key. Well, that's somewhat true, but in terms of Vault context, it is a HashiCorp Vault policy. The policy grants access to the API key. And so it starts to throw us for a loop when we really need to somewhat walk backwards from the way we often think about it. Oftentimes we think about from the actual identity of whether it's the user or the machine that ultimately needs access to the secret. And so as we start to walk backwards, who's associated with the policy? So policies are associated to whether it's a user account or in this particular case, an Active Directory group. So an Active Directory group is granted access to the Vault policy. And then we start to walk back again to, I have a particular user account in an Active Directory group, which then has access to the given policy. And so we kind of see that now in a linear format to where the user is part of an Active Directory group. And so this assumes that the user account hasn't been individually specified as part of the given policy. So in that case, it would be the user is not assigned a policy out of band of the group. So the user is part of a group. The group is then associated with a Vault policy, and that given Vault policy is then assigned access or granted access to the particular API key. And so this is great. We're understanding how access is granted. We can start to see how we can visually map out what the access looks like. The challenge then becomes, what happens when this gets more complex? The user is part of multiple Active Directory groups, and those multiple Active Directory groups have individual policies or potentially multiple policies associated with them. This is where some of the challenge becomes of understanding the context of let's say the Vault policy as code. It's difficult for me to wrap my head around what level of access is being granted in totality for, let's say, an individual user because of this policy change or what the policy actually impacts, as well as the AD membership, which is actually in a lot of ways disconnected from the actual HashiCorp Vault compartment itself. And so it's the case of, I've associated an Active Directory group into Vault and I've granted access via those policies. But if on the AD side, the users are added or removed from an Active Directory group, it's hard to keep understanding of who has access to what. And so if we start to map it out in somewhat of a visualization, we can start to see how some of that access might play out. And what we'll actually do is we'll jump into Neo4j itself to start to see this. And so one of the examples I have is secrets. I have a number of secrets that I want to grant access to, and we'll take a look at how that access is granted. So in this particular case, I may have a secret for, let's say, IT. And for that secret, I want to know what policies are granting access to that secret. So we started to step back through kind of that context. And I may say, you know what, who has access via IT? And in that case, it might be, in this particular case, sableman1 has access to that secret. But we also see that some of these other secrets as part of our secret backend are being granted access by another policy, which is a reporter policy that I happen to have. And so this provides us a capability to start understanding who has access to what, how they're being granted access to certain things, and really start to understand that context of how can I visualize what this policy grants outside of just the capabilities of what the policy, what the code is written as of the policy. And so that provides us that example. So we will step back into our slides And similarly, we can start to visualize dynamic credentials as well. So very similar scenario with the static secrets. If I want to grant someone access to a Postgres database, who has access? So it would be the database role associated with the database backend. We walk through the same process. I've provided an Active Directory group with access to the policy. The policy has access to the DB role. The user then has access into the Active Directory group. So as we can start to see and visualize, there's a lot of layers of intricacy in terms of interconnected components that we need to understand, but also it becomes very challenging to be able to conceptualize those in our head just by looking at the policy and understanding how our Vault instance is configured. And so we'll jump into looking at the backend for the database. So if we take a look here, we can see that for my database. So I want to expand that. So it's part of the mount point of my Vault instance, but there's a read-only role. So there's a read-only database role for the database, database backend. And as part of that, I have a DB audit policy that is associated with the particular database role. And then we start to continue walking back that path to understand we've got an Active Directory group, which is named DB admins, has been granted access to the read-only role in HashiCorp Vault via the DB audit policy, which is great. We've got the start, but then the challenge becomes, how can I walk that layer back to understand who actually has access? So in this particular case, I've granted mread access to the read-only database role in HashiCorp Vault because mread is a member of the DB admins group in Active Directory, and that group has been assigned the policy of DB audit via Vault. And so what this does is we've got these layers pulling data back from Vault. This data is back from Vault. This data is back from Vault. This data is back from Vault, and I've got the association, but this piece of data is actually being pulled back from Active Directory. So that's where we start to talk about the various components of intelligence gathering to be able to see that there's a missing link if I'm only grabbing data just out of HashiCorp Vault. And so the challenge becomes, how can I interface with the other disparate systems, such as Active Directory? How can I start to take a look at things like what is the Splunk logging looking like from an audit log perspective, and start to be able to tie that data together to be able to get a full sense of what the actual totality of the access looks like, not just what I can see in a HashiCorp Vault policy, which then maps back to an association with an Active Directory group, which then maps back to an Active Directory user, but I can start to all see that in totality. And so at this point, I'm gaining greater context than I normally would, simply because I'm able to interrogate those systems and aggregate that information into a single point where I can view the different interrelationships between all of these components. And so what this really does is start to unlock the capability of understanding what the security posture looks like for our HashiCorp Vault instance in terms of access granted in the environment. So one of the things I didn't map out yet was kind of back to the Git integration. So the idea could potentially be, it's really tiny down here, but we can see what we term as a policy path, which is being granted access by the given policy. So there's a line or a particular path granted in the DB audit policy that specifies how I was granted access to this given role. There's the same thing for the secrets. And so what that allows us to see is this particular aspect of the policy grants me access to this data. And the power in that is, in my opinion, to start to expand it out into further use cases where I can start to integrate with Git to say, you know what, this particular path was granted access via this commit to the policy, this is assuming that we're leveraging GitOps for managing our HashiCorp Vault policies. And so that allows us to start to be able to see and enrich the data that we're gathering from all these disparate sources to see how, yes, this person was granted access via this method, and it was via this policy, and this policy was changed on this particular time via this commit. And then we can start to layer on additional pieces of data like the audit log to say, okay, the user accessed this particular path or this data point on this particular date or this particular time. And then, not to get too far ahead, but there's also the possibility of just having collection of massive amounts of data to where you start to see, okay, where or and how was that particular, in this case, dynamic credential used, to start to see, okay, my database backend granted me access to this particular database, and the user accessed these particular credentials to manipulate the database, and being able to tie that in a visual way to see, okay, access was granted on this particular date. These were the credentials that were used, and these were the particular operations that were performed via that credential. So in the case of the database credentials, it would generate me that dynamic user account. And then I could start to see and map all those things back in a more visual path or a visual way, as opposed to, in my opinion, and looking at sort of the code and the configuration and walking through various commands to try and parse that information together. And so for me, it started to become a realization of, you start to think about how long something like this might take to actually walk through the process. Obviously, those that are really intimate and familiar with the kind of the paths we walk through can grasp that and understand how they might start to parse that information out. But it's a challenging process, and one of those scenarios where the speed at which we can move feels only so fast, given that we have to try to ingest all these various data points and provide that context around it. So that's one of the challenges that I think this helps to start to unlock or address, in my opinion, is just the fact that I can visualize the data and what's going on. So similar to kind of what we've done traditionally with diagrams and whether it's mind maps or various aspects of learning and consuming information, it's oftentimes the visual way is the most easiest way for us to wrap our heads around things. And so kind of the next evolution of some of those things would potentially be, how can I visualize policy change impact? And I talked a little bit about this, but conceptually, as we looked and saw what we were visualizing in Neo4j, the capability to visualize changes really seems something we could really do pretty easily. The fact that I already know what data is in Vault from a secret standpoint, as well as who has access via what and how they're granted access, I can then potentially overlay another, let's say a V1 policy set of relationships with a V2 policy set of relationships. And potentially this could be exposed via something like an API endpoint, where as part of your GitOps policy chain CI/CD pipeline, you have a sort of a blocking stage that says, you know what, give me the policy change impact and what that looks like, and let me visualize what that change is going to be. So in this particular case, V1 policy was read-only access, or just, read-only access to the API key. And the change that was made in V2 might have been read and delete access to the API key. And so potentially if this API key was nested a couple of layers deep and somebody made a policy change, it may have been unintentional that they were granting access or delete capability to the API key. And ultimately, this isn't something that's going to show up on the audit log until the unsuspecting user, or maybe they were suspecting, deletes the API key. Or maybe it was an update to the API key and they've updated the API key for whatever reason. And maybe they were only supposed to be granted read access. This is one of the more challenging things to start to parse through and understand from a policy creation perspective is what is the impact of this particular change? And for me, this also plays really well to kind of that least privilege mentality that oftentimes we're looking to strive towards, but in practice, it's very difficult. One of the challenges from a policy creation standpoint is I create the policy and I test it out. Maybe I can test it out. Maybe I can't test it out really well. And I'm pounding my head trying to figure out how to grant access to this particular policy. And oftentimes what ends up happening, unfortunately, is we get a little more permissive in terms of what we're granting access to simply to grant access and aren't as least privileged as we could be, simply because it's challenging to understand what the impact of a certain policy change might be. So that ends the talk. Hopefully it was very helpful. And really the goal and the outcome was to understand how visualization can really help our context of understanding the interrelationship of different components, and as well as access to secrets and dynamic credentials in those various aspects.